Hi everyone, welcome back. In today's video, we'll be solving three problems from IIT JAM 2026. This will be the first part. There are many more parts to come. So I've chosen three very simple problems. Let's go ahead and see how we get the answer. Right. So we've been given a Boolean expression and we have to simplify it. So if you observe uh, the first term and the third term, right? I can group them. And similarly, second and last term, I can group them. Doing so, this is what I get. B bar, C bar, inside parenthesis, A bar plus A, and BC bar, again inside parenthesis, A bar plus A. So, so this is 1, right? A bar plus A is 1. I get B bar, C bar plus BC. Again, grouping. Wait, did I make a mistake? This is supposed to be BC bar, guys. So B bar plus B times C bar. My Y equals C bar. There we go. Moving on to the second problem. Okay, we have a modified 1D harmonic oscillator potential, and they're asking us to find the change in ground state energy. Okay, so unmodified harmonic oscillator potential looks like this, which is also equal to half m omega square x square. Now we have modified potential. Let me call it v prime of x. A linear term is added to it. Okay, 3ax. Okay, so before that, so whenever to your unmodified potential, let's say a constant term is added, call it u naught, right? So whenever this constant term is added, it also reflects in your energy eigenvalues. So, alright, my new energy eigenvalues would be the old one plus u naught. The old one is obviously half n plus half h cut omega u naught. We're going to do something similar here. So we will extract the constant term from the modified potential. And how do we do that? We complete the square. Ah no, this would actually be 6a over kx. So inside the parenthesis, I will add and subtract b over 2a whole square, which is 3a over k whole square minus 3a over k the whole square. If you observe, this is a square, this is 2ab, this is b square. So my v prime of x can be written as half k k x plus 3a over k the whole square minus half k 3a over k the whole square. So this thing is my constant term, and my change in ground state energy, the 0 point energy, is this minus, which equals, yeah. And the question also asked me to find this at a equals 2 and k equals 1. When I do that, 6 square 36 minus 18, which is in fact the correct answer. Okay, they're given us an ordinary differential equation. You might all be familiar with it. It's the simple harmonic SHM, simple harmonic motion differential equation. Okay, for those of you who don't know the standard solution, here's how you obtain it. You write down the ansatz. I hope I'm spelling that right. It's an educated guess of how your solution is supposed to look like. In this case, let me make the guess that y equals e power mt. When I plug this into my differential equation, the first term twice it's twice differentiated, so m square power mt, and I have omega square e power mt. So when I cancel the e power mt's, I'm left with square equals minus omega square, or m equals plus or minus I omega, right? So now my y can be written as a linear combination of uh, for different m's power I omega t plus c2 power minus I omega t. This can also be written in a different form, that is in terms of sine and cosine. Cos omega t and sine omega t. Both of these forms are equivalent. They come from the Euler formula, which is e power I theta is cos of theta plus I sine of theta. Uh, so the form which we will be choosing today to solve this problem will be this one, the one in terms of sine and cosine. Uh, for other problems, it's all a matter of convenience and choice. Okay, so let me differentiate this once. I obtain minus a omega cos omega t and b omega. Oh no, that becomes sine. So sorry about that. Sine, and this would be cos. Okay, perfect. And now one of my boundary condition is that the first derivative at t equals 0 equals 1. So dy by dt at t equals 0 should be 1. And sine at t equals 0 is 0. And cos at 0 is 1. So my b is 1 over omega. And in order to determine a, I will have to use the second boundary condition. That is y at t equals 0 is half. Y at t equals 0 is half, which implies a a which implies a is half. Okay, and now my solution y of t looks something like this: a cos omega t plus 1 over omega sine omega t, and I have to find the value at t equals pi over 2 omega. T equals pi over 2 omega, which is half cos omega's cancel pi over 2 plus 1 over omega sine pi over 2, and this is 0, this becomes 1, so the answer is 1 over omega, which matches option A. Yeah, so that is it, guys. More videos are coming. Yeah, stay tuned. Bye bye.